There we go. And you're muted, Andre.
All right. Good morning, everyone. So a little bit of technical difficulties, but we're maintaining pretty well. So thank you everyone for coming. We're very excited to have everyone here. We are DC-MUSE. We're the Center for Decarbonizing Chemical Manufacturing Using Sustainable Electrification. I'm serving as the director, and Elizabeth is serving as the deputy director, and we're a consortium of several institutions, about 12 universities, 2 national labs, and our mission is on decarbonizing, developing pathways for sustainable electrification and using new processes development. So very excited for this panel today. And if you get a chance, take a look at our website, which is dc-muse.org. And you can learn more about our organization. We're also on LinkedIn, so please check us out on LinkedIn as well. And I will hand this back over. Very excited to have you guys here and just enjoy this seminar.
Excellent, thank you. And so I'm going to go ahead and get started as the host here. I'm going to actually put Andre, Simon, and Frank. I'm actually going to spotlight our panelists. Let's see if I can. I'm going to leave us as in this format so that you guys can come back on and interrupt if needed anything. So thank you very much for joining the panel on the sustainable plastics life cycle. We're super excited to be able to have this panel. This is part of an ongoing webinar series from DC-MUSE. We have them approximately monthly, and this will be one of our first panels rather than seminar type formats. So I'm Elizabeth Bittinger, and as Andre pointed out, I am the Deputy Director of DC-MUSE. I'm also an Associate Professor of Chemical Engineering at the City College of New York. And so I will be moderating this panel today. And this is a very timely topic. There's been a lot of news even this week and a lot of actions being taken about the need for addressing the plastics life cycle. And that we know that plastics are a vital part of our everyday lives and have been transformative to the quality of life that we have. But there are also significant impacts to our health, environment, and climate change because of the production and recycle, or their lack of recycle, of plastics. And how their entire life cycle. And so what I want to do is I want to start this panel out with a few questions, and then we're going to open it up to the audience to ask questions. So please do thinking about those, and that you can put them in the Q&A or in the chat. Either one of those is fine. We will be managing that. Karl, would I mind going ahead and introducing yourself in 2 to 3 minutes, and why do you think, what's your perspective on the plastics life cycle as well, and then we'll get started with everybody else doing the same.
Sure, absolutely, yeah, and thanks Elizabeth and Frank and Simon and Andre for invitation to participate today. This is great, and I'm honored to be a panelist. So my name is Karl Albrecht. So I'm the research manager for the catalysis research group at ADM. I'm a chemical engineer by training. I consider myself a heterogeneous catalysis expert. And so in my 6.5 years at ADM, and then about 9.5 years before that at Pacific Northwest National Lab, I've done really similar work in both cases, right? Where discovery of catalysts for, kind of quote unquote biorenewables, whether that's sugar, fermentation products, oils, you kind of name it. I've looked at a lot of different feedstocks over the course of my career thus far. And, you know, whether it's the upstream to kind of clean things up so the catalyst can work better, or the downstream processes to think about, you know, how do we get to polymer grade, or how do we start making monomers and things of that nature, are really where a lot of my experience and my expertise lies. So kind of coming at it from a biorenewable standpoint, as it were, you know, big quotes around that, right? So life cycle. Yeah. So my perspective on the life cycle, right? It comes back to where and the sustainability, especially of the life cycle, it comes back to, you know, thinking about it kind of holistically from start to end, right? And especially kind of on the upstream side, working for ADM and a lot of where my experience is at, in a lot of cases, how do we make these economical, right? There's a lot of technology that exists out there today for converting things into, you know, monomers that we're either familiar with, things like adipic acid, you know, butadiene, you know, maybe some things that are even advantaged, right? That have some better biodegradability, things like polylactic acid, and, you know, can we use lactic acid and things of that nature? And ADM was active in that space for a while. And then what are some of the things that we can do that are a little bit different than where petroleum's coming from also, right? So, you know, things like C9 diacids that, you know, you can get to from oleic acid and things of that nature. So kind of thinking about it on the upstream side, and then how do we make that economical, right? Because at the end of the day, in a free market economy, we're going to have to make it such that we can make these things, get them into a supply chain, and convince people to kind of like take them out and use them and start to incorporate them. And then as we go through, the more that we can improve the recyclability of those, right? So is that going to be something like a biodegradability, like in a polylactic acid? Or is that going to be something that breaks down easier so that we can, you know, do a chemical recycling on the back end? And thinking about that from the start all the way through to the back end, you know, it's not just in my mind, of course, you know, how do we replace oil? It's how do we make things that are at least equivalent or even better in cases, because we have access to different kinds of molecules, build those up, and then think about, and how do we get some consistency, I would say, on the back end, so that there's expectations on how that back end is going to be, you know, applied at the end. Are they expected to biodegrade? Are they expected to be recycled? How do we set those expectations, either through, you know, incentives, mandates, whatever, you know, even just consortia, I would say, within industry, to say, look, we're going to make this, it's going to be consistent at the end so that we can do the recycling. Because at the end of the day, in my opinion, you know, it's all driven by the economics, right? You have to have economical processes, and you have to have the incentive for the companies to want to go take those, recycle them, and put them back into the life cycle so that they kind of keep going back around, right? So.
Thank you. Jason, would you like to introduce yourself? And then I think also you look clearly at the whole life cycle. So maybe you could also introduce to the audience who's not as familiar. What does the plastics life cycle look like, in addition to your introduction?
Sure, yeah. And first, I'll echo what Karl said too. Thanks for having me. I'm excited to be here and chat about this. So my name is Jason DeVoe, and I'm a researcher at the National Renewable Energy Lab, which is in Golden, Colorado. The lab as a whole focuses on a lot around renewable energy, including plastics. So I work primarily in the Bottle Consortium, which is a consortium with many national labs and industry partners and universities. And we're focused mostly on recycling today's plastics, like major commodity plastics, as well as maybe some more niche plastics, as well as redesigning those plastics for sort of tomorrow's plastic future. And the main focus there is in developing scalable and deployable technologies, whether that be for the recycling or for the displacement or replacement of polymers. And I operate mostly in the process modeling, techno-economic analysis, and life cycle assessment space. So to sort of provide a holistic analysis of proposed technologies, existing technologies, et cetera, to ensure that if we are pursuing a recycling technology, that it is both, well, hopefully that you can check off quite a few criteria. Oftentimes you can't check off every criteria, but hopefully you're developing something, as Karl said, that's economical, such that there's incentive to do it, and also something that has less impacts, say climate change impact or water usage, land usage, things of that nature. So that's really my space and sort of the Bottle Consortium as a whole. So a bit about the plastics life cycle. I can definitely comment briefly about this, although there's a lot of detail here that matters, but we'll come at it at sort of a high level. So most plastics today are produced from petrochemical sources. So oil is extracted, refined to various intermediates, and then they're purified to monomeric units that are then polymerized to your polymer. That polymer then undergoes a lot of different steps until it reaches a product. It could involve compounding, blow molding, et cetera, et cetera. So for example, for a bottle, you might get a PET bottle, you might get a pellet. That pellet might be compounded with antioxidants, stabilizers, colorants. It can then undergo solid state polymerization to increase the material properties such that it can become a bottle. And then it's stretch blow molded into a bottle. And then that bottle has labels and content put into it. And then that bottle makes it to you. So that whole upstream part is quite complex, quite scaled, and obviously very established, as we see a lot of plastics. Once it gets to the consumer, so say you purchase that bottle, there's a lot of complicating factors here, but generally you might use it and then dispose of it or recycle it. So disposal and recycling looks different across the world, and even within the US, there's a lot of differences between how waste and recycling can be managed. And so if you recycle it, it makes its way to what's called a material recovery facility, or MRF is usually how you'll hear it, or MRF if you're sort of doing an acronym there. And at the MRF, it gets sorted from a variety of other plastics. If you're in a space where there's single stream recycling, which is where you put all your plastics in one bin, and then this facility separates them. Obviously, that's not the most efficient process. There's a lot of losses and contamination that result during that sortation, but ultimately it makes it through that facility and gets compounded into a bale, and that bale can then be used to recycle it. So say if it goes to mechanical recycling, they might do a secondary sortation, extrude that polymer to recycle it, and then it can become, it can sort of re-enter that processing life cycle and hopefully make it into, say, another bottle or a product like a carpet, for example. So hopefully that gives a bit of context. As I said, there's a lot of details. That was just one plastic as an example, but hopefully that sets the stage for folks that might not be as familiar.
That's helpful. Thank you. And Nahomi, you come at this area in quite a different perspective, and we appreciate you joining today. So please introduce yourself and tell how you're engaged with the plastic life cycle.
Yeah, thank you. And then thank you for inviting me. I mean, I feel so alien to, I don't know, the ideas or topics, probably because I don't have any engineering background. And then what we do is mostly for the policy advisory, or the making of frameworks, and also we also assist companies in the developing countries, but probably it's kind of a different technology level from what you're just discussing. But so then my name is Nahomi Nishio. I work at Circular Economy and Green Industry Division of the United Nations Industrial Development Organization. It's called UNIDO. And then we are the special agency of the UN organizations, and the mandate is to support inclusive and sustainable industrial development for developing countries and emerging economies to achieve SDG 9. So, and then our division is to support it through the promotion of resource efficient and circular economy practices in the industry and industry or the states, I mean that the member states, for the member states, government of the member states. So my priority work is to promote plastic circular economy in this division and in developing countries to address plastic pollution. And then currently I'm working with the government of Nigeria, Egypt, South Africa, India, and Kenya. So probably what I'm seeing is totally different from that what you're seeing. But anyway, so what I can contribute is probably that how, well, the aspect from the developing countries, and then also private sectors in the developing countries, and the policy landscape of those countries in terms of the plastic life cycle plastic life cycle, or we call it a plastic value chain, actually, that in terms of developing that industrial industry within the country. So, but this value chain could be also global. No, these days those supply chains aspect is a global. But anyways, within this work for promoting circular economy, we emphasize the importance of the product design, no, with the circular economy principles that product has to go, make it circle. With the so that we can significantly reduce the waste or any other pollutants to be generated possible from the products after use by having the idea of how the product would be treated after consumption and or at the end of life. No, this at the end of life situation is so different in those countries. That where we work with, you need to work with. So I hope that the scientist or technology holder in the developed countries have it in their mind with these aspects to make the product. And then what we do is, as you said, mostly policy advisory, but sometimes technical assistance to not only the governments, but also the industry, the private sector. We go into the companies actually providing sometimes advisory to those companies to work with. And then to implement, to make it enable the sustainable solution at each stage of the plastic life cycle across plastic value chain. What we do is, because the purpose of our intervention is to address plastic pollution, no? So then mostly we work with single-use plastic products. And then again, the Jason explained the life cycle of the plastic so detailed, so I don't probably need to retaliate, but from our perspective, the definition of life cycle is it's similar to the Jason's, but also this definition itself is in question under this current ongoing discussion of the international legally binding instrument, like we call the plastic treaty, but it might be coming. So what is the life cycle is a kind of a difficult question to answer, no? But from our point of view, like all the players, the producers, users, brand owners, retailers, distributors, logistics companies, or consumers, or waste management organization, like this, not only recyclers, but also, of course, the collectors or recyclers, or municipalities also are stakeholders. So then all these people what in the value chain involves in this life cycle of the plastic, no? So with that, I just give back the floor to you, Elizabeth.
Thank you. And your perspective is so important in this because these products are absolutely global, and even if they start in one country, they end up elsewhere, and so that's a very important aspect, and that in the developing world we want to make sure that we help them take our lessons learned and not repeat all of the things that we are that we've found out maybe weren't the best practice, and help her skip those steps, and so there's opportunities for us to learn in both directions for sure, and this is a societal problem. It's not just a problem that scientists and engineers can address on their own. They need all of society to engage and inform us. If we make something that no one wants, it doesn't matter, right? Or as Karl pointed out, no one will buy, right? That it won't matter. So we have to make sure that we're thinking about all these aspects. So thank you for all the introductions. And so one of the questions, sometimes people will just say, well, we've got this big plastics problem. Why don't we just get rid of all plastics, stop manufacturing them, change to something else? Maybe Nahomi, you can start with, that thought, and where's the value in plastics?
I mean, that not all the plastic is bad guys, no? So that's for sure. Like, so that I think we should distinguish the problems, and then, like discussion ongoing, because that even this plastic treaty discussion, we are not talking about like, giving up the plastics, for everything. So right now that the problem is the plastic easy to the leaking to the environment, which is mostly the packaging. So then the packaging is a kind of the target of this treaty, or what to do with this, and especially in the EU, that we are phasing out this single-use plastics, from the virgin material. So I mean that it's. I mean that we as an industrial development organization, we don't say that we should eliminate all the plastics, because it's also not realistic.
Well, it's not only just not realistic, but we have a lot of value in plastics too, right? So, and Jason or Karl, do you want to? I know that's just we know that we need plastics, but it's like looking at it from the other side. Why do we need that, or what are the opportunities for some replacements?
Karl, do you want to jump in first? I saw. Go ahead.
No, go ahead, Jason. You beat me off mute. So
Cool. Yeah, I think you'll often hear examples of cases where plastics are just very difficult to replace with anything else. I think folks are likely aware of things like in medical usage, it's difficult to sterilize large quantities of disposable materials in instances where we require disposable materials in the medical space, with other materials like, say, glass or metal or things of that nature. And then more broadly too, when you think about replacing plastics with something else, that other material also has a footprint. And oftentimes you can achieve a certain performance with plastics with less material, just due to the nature of plastics. And so it's not as simple as saying, if we want to package this with renewable material, say like paper or something of that nature, that it's therefore better than plastic. In some instances, it definitely can be, but in all instances, that's not the case. So there are, I guess, to just summarize that point, there are places where plastics are just difficult to replace if your goal is to make something more sustainable. The other part of that is where we can replace things, I think heavily depends on how many times things can be reused. So it's not necessarily about recycling, but it's maybe about reuse in this instance, because if you do want to replace plastics with something, as what you would be replacing with does have a footprint, as I mentioned, you have to ensure that you can use it sufficient times to sort of offset maybe that higher footprint. And that, I think, gets sort of ties into what Nahomi was saying with the single-use plastics and bans that are happening around the world with regard to that, and emphasizing the reuse to stretch the lifetime of the material.
Karl?
yeah, just, Jason, you went exactly where I was headed initially too, which was, you really have to think about it by application, and sector is not quite the right word, but where are we actually talking about, right? So, I mean, packaging certainly comes into it, right? And things like, plastic soda bottles and things of that nature, could you replace those with aluminum? Probably, and maybe those are more recyclable, but then you have to start thinking about, are those heavier to transport, and what's the effect on the cycle, life cycle analysis there, right? You start to think about medical applications. I mean, there's, plastics has really changed a lot of medical applications, sterilization, everything from, the NICU, incubators that they have the preemies in, all the way through surgical implementations, and everything else are made of plastic. I mean, there's a place for plastic in a lot of things. And, I'm sitting here kind of looking around my office and thinking, okay, well, think about all the things that are made of plastic in here, right? I mean, even like gears in the chair that make it go up and down and things of that nature are made of plastic. I mean, there's going to be a lot of applications in places where plastic is probably the cheapest and is just going to make sense, right? And then, Nahomi, I think, brought up a really great point too, right? I mean, it gets into the environment and things of that nature, but, plastic or paper bags, right, aren't a concern. Like, we're not worried about, hey, there's paper bags, for example, polluting the environment. And why is that? And I think that's because it breaks down. And so with Jason's comment, where you start thinking about, okay, what are the applications and fit for purpose on this? Can we come into things that are biodegradable potentially, so that, when they leak into the environment, they ultimately have a fate that becomes a biodegradability, and we don't find them in the environment then ultimately, right? And so I think you have to start thinking about it from, okay, what applications are we really talking about? what do we need that end state to be? How recyclable are they? And I'm just kind of repeating, I think, what Jason and Nahomi said at this point, but it's a very, very complex process. And when you pull one lever because of something else changes, right? One of the reasons that we use plastic soda bottles so much is because, you know, the low oxygen permeability. Can you find another replacement with low oxygen permeability so that your beer doesn't go stale, right? Or something else, right? Your pop loses its CO2 or something like that over time. There's just so many challenges that end up being associated when you say, look, I'm going to pull this lever here. Well, maybe they're heavier now, and you inadvertently increase the, you know, the LCA and the CO2 emissions because it just takes more energy to get that to market now, so that people can buy their pop, right? So yeah, no, that's what I wanted to add.
Thank you. So it looks like we have our first question in the system, and several of you have mentioned the medical devices, and so this was actually a specific to the medical device question in comments, and that's how do medical devices get recycled or treated? And there was a comment especially about single-use auto injectors and similar type things. First of all, I guess I would ask is, are they recycled? And then how are they? Maybe Jason, do you have an information on that?
Actually, I'm not super versed here. I can take a
Okay.
pass,
Yeah.
but maybe others can fill in with my lack of knowledge. One complicating factor in the medical industry will likely be the biological contamination, right? The risk of having a biohazard that would then compound through recycling steps and potentially be hazardous to reuse. So my guess would be that in most instances where items could be contaminated with biological hazards, those would be disposed of and not recycled. Now, could they be recycled? Most likely, but that would require sort of a second sterilization step prior to recycling. So that would be my guess. But yeah, unfortunately, I actually am not super versed here. Good question, though.
Karl and Nahomi, do you have anything you'd like to add on that?
I probably can come in just to, like, from my experience in the project in the developing countries, well, that we don't promote circular economy in the medical equipment or medical use. I mean, of the single use, no, because that it requires as Jason mentioned, like a different waste stream. So then it shouldn't go into the regular waste stream, no. It's for that I would say that we need to promote more proper, appropriate management of the waste rather than just promoting the recycling. So then, like, of course, it's better to recycle what you can recycle, but treatment is, proper treatment is necessary. So for that, I think more not education, but training, probably proper training is requirement, I think.
Okay. Yeah, so there's a social aspect to this for sure. One thing that I will say that comes with our next question here is that possibly I believe that most of the medical waste is actually incinerated today. And that instead of incineration, possibly pyrolysis could be a way of converting to something that's of more value than just CO2 and water and some ash, right? And so the next question we have is, what are your thoughts on pyrolysis as a mean to recycle plastics and reuse items in such as fuels? So recycling them to via pyrolysis and then either making them into plastics or fuels. So Jason,
I was going to say,
okay, Karl, please.
No, sorry,
ahead.
Elizabeth. I was just going to say, like, that's where I was headed on the medical device question. Actually, is kind of what you said was, I think Jason mentioned a lot of the heterogeneity that ends up in potentially, recycling, especially single stream recycle and things of that nature. And I think the pyrolysis is a really viable option to break, what can be kind of heterogeneous, diverse sets of different compounds back down into smaller building blocks and then either convert those into new monomers. And I know there's others that are looking into, can we make, gasoline or diesel and things of that nature and do some offsets that way, right? So I'm actually a big fan of the pyrolysis, and can we take those streams, do it? I worked in biomass pyrolysis for a while. I think plastics pyrolysis is an easier problem because you don't necessarily have all of the different kinds of oxygenated materials in there that tend to throw a lot of challenges chemically at you when you try to do pyrolysis with biomass. It's a bit of a challenging problem, and I think it's more amenable to things like, okay, maybe I can feed this into an FCC type unit and get into a gasoline stream or something of that nature. Or even, if you're really clever about it and you try to minimize the amount of heterogeneity, maybe you can start to do a little bit more gentle type pyrolysis or even a chemical treatment to break it back into the individual constituents, which wouldn't quite be pyrolysis, but would fit into that. Like, hey, what can I do with this by breaking it back down and apart and putting it into something? So the medical waste made me think about that. It's like, yeah, you definitely don't want to reuse the medical waste, right? But is there something else you can do to kind of upcycle that and reuse that again into a fuel or put it back into a monomer form so that you can go and make plastic out of it again? And along the way, it's going to go through that high temperature. It's going to sterilize all that kind of stuff. And then you're going to be able to make the next set out of that. And then that becomes kind of the life cycle loop at that point.
Okay. Thank you. Jason, did you want to contribute to that?
Yeah, maybe a twofold answer. The first part being that pyrolysis, yeah, as a means for conversion of waste plastic to other products, can potentially be viable economically, and environmentally, but it largely depends on what you are producing. When you think about it more as a recycling technology, so for example, taking in, like, say, polyethylene and going back to polyethylene, like what we call closed loop, meaning going from your plastic to the same product, that is quite limited and very, very difficult to do with that technology. But if you go more towards things like, I'm trying to think of a simpler word, but like aromatic monomers like benzene, toluene, xylene, that sort of fraction of crude oil, it can be potentially promising. So that was the first part. Second part, I guess, more focused on medical devices and the potential for pyrolysis in that space. I do think that for like medical plastic waste, there is the potential there. I think there's some complexity in transport of the waste that would be a biohazard, because then you're exposing workers and there's potential for leakage. So I think that it would sort of hinge on that. And then that's just like plastic waste from the medical industry. As far as medical devices itself, I don't know if pyrolysis would necessarily be the best choice, because devices like electronics and other things with high plastic content, but not solely plastic, will have a slew of things like metals, flame retardants, etc., that would likely make the pyrolysis process infeasible for that sort of stream.
And we've got great questions coming in. Thank you. So I wanna so we've got questions about this. We've been talking about now mechanical recycling. We talked about chemical recycling. And so there is actually a question in here about the benefits between mechanical and chemical recycling. And I think we can talk about this from a societal and availability context that Nahomi, I think you could talk on, and then we can also talk about it from the technical aspects that both Jason, you can bring from the life cycle, and Karl, you can think about from more the manufacturing side. So Nahomi, maybe would you mind starting thinking, if the plastic is to be recycled, what are the considerations between that mechanical recycling, as Jason said, taking the same type of material and really turning it back into the same type of material, or versus breaking it down and making new chemicals out of it?
Yes. So I can talk about the developing countries situation, probably. So mechanical recycling could be because that what it's in there doesn't change. No, so then like how it's collected is kind of very important, and the where this plastic waste was. the most of the cases in the developing country, it was collected from the landfill or streets, or like it's not the clean material. So then it's most of the cases it's really difficult to recycle, but still they do recycle. So then it's in terms of the safety purposes, probably it's not better to bring in material to the same the product stream or material stream. So most of the cases are used as cascaded recycling, in terms of that. But so because that those plastic waste collected in the those developing countries is not clean, so the chemical recycling or this pyrolysis technology might be better in terms of the usage or in terms of recycling technology, but also there is a challenge in terms of the economic viability, So it's really for us always kind of the struggle, which way we should pursue or like promote the idea of this technology.
And so maybe Jason, have you looked at the chemical in depth more at the chemical versus the mechanical recycling, and what are the pros and cons associated with those?
Yeah, we focus a lot on this and have sort of made it a standard to compare whatever we're looking at with mechanical recycling, because as a broad blanket, but what is generally true, particularly for commodity plastics, is mechanical recycling is by far the cheapest and lowest impact process for recycling, but that's not without its limitations. So a few issues that mechanical recycling faces is it requires pretty pure inputs, so non-colored and clean material. So there are, of course, plastic streams that don't conform to that. If you have, say, colored material, or if there's a bunch of other types of plastics or dirt, debris, food, contamination, etc., those cannot necessarily be readily handled by mechanical recycling. I guess the caveat to the colored is it can be mechanically recycled, but you'll get an off-spec sort of ugly product out, right? Like a brown gray that if you were to put that back into packaging, consumers might look at that and say, ooh, what went wrong there? And then there's also the limitation that in the mechanical recycling process, it's not necessarily theoretically infinite, as when you mechanically recycle, you break down the polymer, whether it be through like thermooxidative or various like chain scission mechanisms, where the product you get out is not of the same quality as the product you put in. And so therefore you can't necessarily use it in the same application. So it has a limited number of times where it can be recycled. So sort of where mechanical recycling has a role is for the feedstocks that it can treat, and that it makes sense. It should 100% be applied as a first pass. But because there's limitations, that's where chemical recycling comes in. It will nearly always be more expensive and higher impact because there's many more steps that are involved when compared to something like mechanical recycling. But you can potentially break monomers down or break polymers down back into their building blocks, and then get a same quality polymer back out. Or you can, for example, if you were to pyrolyze it, maybe you can convert that incoming plastic into more valuable products that can be used for other purposes. So it's sort of for a comprehensive recycling infrastructure, both will likely be needed in order to recycle as much waste as possible. Hopefully that wasn't too much detail, sorry.
Oh, thank you. Karl, did you want to comment on this at all?
Yeah, absolutely. Two thoughts. First one is, just to echo Jason and maybe think through a little bit, but those of us of a certain age can remember like back when we were kids, right? Like a lot of napkins and things of that nature, thinking about post-consumer use, cellulosics, right? Papers and things of that nature. And a lot of the napkins that we're used to now are recycled and they're brown. And when I was a kid, right, there was, like I say, you go to McDonald's, you get a white you'd get a white napkin, and then, they switch to the brown napkins, I think, far and away now, because that's just kind of what happens during that recycling process of the water, right? And so, Jason, I think when I hear you say that, you might end up with something off spec, it's down that pathway lies, can we still make polymer out of it? And then if we can, will the consumer actually, be amenable to taking that up? Like, my Coke bottle switches from clear to brown, and will people think that, hey, you know what, that's okay, I don't mind, I understand that it's recycled? Or are they like, oh, that looks dirty now and I'm not going to drink out of that? So there's a lot of consumer acceptance that I think the manufacturers and all along the value chain are really nervous about in that recycling paradigm, where it's like, look, I have to use something that's, virgin PET in that case, so that I can make a clear bottle, so that my consumers will continue to buy it, because, there's, because Pepsi or vice versa. And I don't want to specifically, take Coke and Pepsi by any stretch of the imagination, but, because my competitor is using something else, and then suddenly it's like, oh, I don't want to do that because I have a different in a perception, right? So there's a lot of concern, I think, around consumers on those fronts. So the other one too is, just in recycling, and I think in pyrolysis in general, right? I mean, if you think about what the competition is fresh from oil, there's things like a lot of development that has gone into it in the last 40 or 50 years. There's a lot of depreciated steel in the ground for making things like phthalates and PET and pop bottles. And so it's an uphill climb, right? Because, hey, here comes a feedstock from oil that's pretty homogeneous and well understood at this point. We're going to take that, all of the infrastructure's there, we know just how to handle it, and we're going to put that through. And in contrast, here comes a very heterogeneous material that, yeah, we've recycled, but we've had to pay somebody to go pick up, we've had to pay somebody to sort, we've had to pay somebody to pyrolyze, and now we have to go treat it again, get back into the monomers. And every time somebody touches it along that value chain, you're adding cost to it. And so the cost effectiveness of even just the feedstock, let alone the processing, becomes very challenging from a manufacturing standpoint. I think because you just have to think about, how many times are we going to have to touch this? How many times are we going to have to sort it? Are we going to have to clean it? Then we have to pyrolyze it. Now we have to put it back in the right form, et cetera, right? Whereas oil is, moved in bulk as a commodity through, you can get to the plant, the plants are already built and depreciated, et cetera, right? So it is a really steep hill to climb, I think, on a lot of the recycling infrastructure, even beyond thinking about just, is the consumer, willing to accept and uptake this in a recycling paradigm? But we've had to add so much cost along the way to get it into the form that we need, such that it's polymer grade and we're able to blow mold, or like Jason gave the great examples at the beginning on different ways to make the bottles and things. So
Thank you. So we have about 10 minutes left, and we have been getting some wonderful questions coming in. We're not going to be able to answer all of them, though I think we have a nice holistic kind of wrapping up question that was posted by one of our DC-MUSE members, and I'm going to read it because it's nicely posed here. Plastics tremendously impact climate change, lead to environmental pollution, and impact human health. Eliminating all of these three at once is challenging. How does ADM think about the broader impacts on the materials design? How does Bottle incorporate all of these impacts in the analysis and research pathways? And how does the UN think about the balance of these three impacts, which again is climate change, environmental, and human health impacts on the UN? They have balanced these three impacts when developing a global treaty. And how do you marry all these impacts together with the economics when the externalities are not accounted for? So that's a lot of things to think about. I don't know if the panelists have been watching the Q&A. I'll leave that one up for a moment so that you can see. But I think it's a great question to allow us to each to summarize. So maybe Nahomi, would you like to start with that on the how do you balance this? Yeah.
I mean, that's exactly what we are discussing at this negotiation at Plastic Treaty. Of course, a UN organization is just being secretariat. So then all the member states, like a representative from that each country will discuss and how you want to make this aspect into the Plastic Treaty. But the climate change and pollution and human health, that's all considered right? So then, and then way forward, what's the best to address the challenges of the plastic pollution. So then this externality question is also in the negotiation. Like we are trying to import, not we, but the treaty for negotiation is trying to impose this EPR, extended producer responsibilities, no scheme. So then, like polluter pays role rules to ensure that those externalities is incorporated into that life cycle. So yes, we recognize the importance, and then we recognize that the significance. I mean that into that plastic treaty or negotiation. Thank you.
Thank you. It's certainly it's a complex process. All right, so let's see. Karl, how does ADM think about the broader impacts on this material design?
Yeah, absolutely. And so a few things. One is, like I said before, that our belief is that there are opportunities out there today for, especially on the environmental and some of the human health aspects, right, for biodegradable polymers, I think, and plastics to replace some of the things that we're currently using, right, as single-use materials. So things like polylactic acid, right, that have improved biodegradability. So when you look at that, kind of encompassing, in the spirit of the question, the entire aspects, plant-based, I think, is helpful. I think, especially when you start to think about, okay, so what can I do to lower the carbon intensity and the environmental footprints of the things that I want to ultimately make into the plastics, right? And so we've got initiatives around sustainable agricultural, regenerative agricultural practices where, we're not growing necessarily the corn, but we're going out and contracting with the farmers that are growing the corn to do things like cover crops and some of the practices that are known to enable lower fertilizer, inputs and things of that nature, trying to lower the carbon intensity of that down so that, by the time it reaches our gate, so that when we, do the conversion, do the wet milling of the corn and get to the starch and the fermentation, ultimately to make things like lactic acid, that the carbon intensity of those is lower, right? And so, we really do try to take a holistic view, certainly up through the products that we're making, and then work with partners as they would take that and then move forward and convert that into the plastics and think about, okay, well, what is the ultimate fate of this, right? How are we going to make this? What's the carbon intensity? What's the ultimate fate? Does it end up in the environment? What are the impacts, broader scope around the human impacts as we go forward? But really trying to focus in on the things that we have, control over, which is kind of early on in the supply chain, as it were. And I think that, the less oil that we can bring up out of the ground generally, and then the more that we can keep in sustainability with, plant-based materials is good ultimately for everyone, recognizing that we need to do some work, and we are working in that space to lower the carbon intensity of the materials that we have, and I think have pathways to get there. So I hope that answers that question. That was a big question. So
yeah, it's a big and complicated question that we can spend years trying to address, right? But this is just some of the perspectives. So Jason, do you like to address how Bottle incorporates the climate change, environmental pollution, human health impacts into the analysis and research pathways, and then those economic and externalities?
Yeah. So when we evaluate, say, recycling technology, we metricize all of these impacts, both the economics and environmental and human health impacts, etc. And oftentimes, as I assume where the question is stemming from, it's not true. It's not true that, say, said recycling technology is better in every single instance than virgin production. Maybe it's more expensive, or if you're producing something like PLA, maybe the land use is a lot higher, or maybe the water consumption is a lot more. And so how we sort of look at this is, number one, just take a quantitative approach and evaluate all of those metrics. And then you can try to do something which is termed as multi-criteria decision analysis, which at its heart is maybe an imperfect solution, but at least it's a step to understand how to prioritize the things that are most important. And so what it comprises is to weight your various factors by their importance. So we'll look at a case where we prioritize, say, technical and economic factors, which might represent if you want to deploy something most readily, what technologies look most promising. And then you can look at, say, an environmental and human health impact weighting, which says, rather than say that the high technology readiness level or the cost, we really want to emphasize the environmental and human health performance of this, weight technologies according to that. So that's one step to sort of account for all of those, but it's due to the fact that it's usually not like a slam dunk per se. It's difficult to do, but that's sort of how we approach it.
Thank you. All right, so we've got a couple of, well, we have a lot of questions. We're not going to be able to get through these all. Do we have, but what I want to do is first ask, with the technical difficulties, is it okay that we run just a little bit over, or you guys have to leave? You're good? Jason, you are good? Okay. Thank you. And Naomi, thank you for answering that digitally. And so I think well, we have to pick a favorite question, right? So so one of these is, are there policy initiatives across the world that have worked to enhance circularity of other materials that can be applied to plastics? We have plastic bag bans, but are there other strategies that work that are maybe producer responsibility? And maybe Naomi, you can take a stab at that first. You know, what does a policy look like that can be effective?
I mean, that I can probably introduce that the EU policy, since UNIDO's headquarters is in Austria, Vienna, Austria. And then what we are facing right now, and then the industry facing right now, is also this EU regulation to include the recycled material into the product, like, you know, certain percentage. And then, of course, the banning the single-use plastic bags, instead promoting the biodegradable plastic bag if it's really necessary. No, so then it's charges. It comes with the charges. And then all these, you know, like policy and regulations are motivated already that the EU-based companies to collect all these recycle, for example, like PET bottles, no, like they are buying used PET bottles from everywhere, not only in EU but also in the developing countries. So then, like if it's high quality enough to bring it back to the recycled material to be used in the EU, then the companies are buying it. So this is a kind of the example that how a policy and regulation promote or advance that circularity of the material. No? So yeah, I because I'm also not EU expert, it's just I'm talking from that experience. But I think this is kind of the way I hope, or we hope, that plastic treaty would do something.
Okay, thank you. I'm going to follow up on a couple of other questions that were part of our train of thought. So I'm just got the train of conversation today, and so I'm going to kind of go through these a little bit quickly. I think so. Karl, there was a question when we were talking about, you know, recycling from one product back to the other. There was a question: why is it so difficult to go from, say, PE to PE? You know, polyethylene to polyethylene. Why is that a challenge?
Yeah, and I think Jason might have studied this a little closer than I have, but and that's okay. I just, from what I know about some of the chemistry and some of the different catalysts I think that are out there, I think there's feedstocks that are well, there's catalysts that are amenable to making more of the aromatics, like Jason mentioned, right? And so once you're into a benzene, toluene, xylene stream, those plants and systems are set up to be able to go and selectively make the paraxylene that's going to go into a PET type bottle. I think it's a lot harder to make, especially a polymer grade ethylene starting from kind of an oligomer chain. I think if you were going to take polyethylene, my understanding is what they're looking at more is taking a polyethylene and pyrolyzing that, probably still going over similar types of catalysts to make aromatics and things of that nature, but they're going to look more like gasoline. And so that might not be, it'd be hard to go maybe from polyethylene to polyethylene because you'd have to make ethylene in the middle. And I think that's relatively difficult to do, especially from more of an oligomer or a polymer, right? But you might be able to take polyethylene and go into PET because I think you can have chemistry that's going to do that and head into the aromatics. And so maybe you could make a polyethylene into a PET. Same idea, you could take a polyethylene and get into something that might start to look like gasoline too, right? So I think there's opportunities in there to take polyethylene, but I think in some cases, in some polymers based on their chemical identity, the coming back to the same type of plastic, specifically I'm thinking about polyethylene here, might be pretty challenging to just get back to a polymer grade ethylene from the polyethylene. So I'm going to stop there and let Jason correct me on the parts that I had wrong on that, because it's, like I said, I'm not an expert in that space. It's just kind of from reading more C&E news type articles and trying to understand what the state of the art is out there. So
Yeah, not much to add there. Karl covered it well. Essentially, it's a thermodynamic yield issue of getting back to ethylene in large quantities is difficult. You do get some ethylene, so you can go back to you could go back to polyethylene, but you're limited in the amount that you could get back.
Okay, thank you. And so what I'd like to do is I would like to give everybody an opportunity to have some closing remarks, final thoughts, so that we can wrap up here. I respect everybody's time, but appreciate all of the great conversation that we've had today. And so I will start and maybe on the technical side first. Maybe Jason, would you like to give some final wrapping remarks?
Sure. Sort of a broad look, I guess, at the plastics life cycle from more of a technical aspect is I think there's a large need to incentivize recycling, which often comes down to economic policy to incentivize infrastructure for collection, sortation, and development of recycling. So I think that's sort of a key area to help increase the sustainability of plastics. And then I guess more on the consumer note, areas in which we can all improve that I generally like to highlight are where you can make sure to reuse plastics or just items, right? So like bring your own coffee cup. Every little thing counts. And when you can recycle, make sure that you do, which I know it's complicated, but do your best, and I think we can all move towards a collective, more circular plastics future.
Thank you. And Karl?
yeah, no, I absolutely, Jason. I think what I would add to that too is the economics are going to be critical, right? I mean, we're going to have the incentives there to be able to compete, but also I don't want to downplay the role of consumer adoption ultimately, and maybe there's a correlation to be drawn kind of ongoing in electric vehicles where a lot of the technology has improved dramatically, right? But folks still have, whether it's range anxiety or whatever in electric vehicles, and adoption has slowed a little bit, right? So it's not just the incentives. I would say it's also some clever marketing and really an opportunity for some public-private partnerships, I think, to get the word out that, hey, you know what, the way your plastics look are going to change because we're doing better things. But how do we make that amenable to the consumer, but even favorable to the consumer, right? And so not just the incentives, not just the technologies, not just, how do we get there, both, doing things and, in the laboratory at commercial scale in the plants and are the right incentives in the government in place, but how do we start to communicate and talk with folks so that they're willing to uptake these things? Because ultimately, economics relies on the demand, right? We can put all the supply in that we want, but if people aren't going to buy them, then that's not going to work regardless of incentives. So I think there needs to be a lot of opportunity and a lot of thinking through how do we get consumer uptake of these things, get folks comfortable with it, and so that we can, if we need to, change how it looks and change the types of things that we produce so that it is circular and better for the economy and the environment and human health, like the one question asked. So
Yes, thank you. And Nahomi?
I mean, I don't have much to add. to that. But yeah, well, that since your audience and then your the members are mostly for the researchers and in engineering, engineers, no. So then we are hoping. I'm hoping that I saw that some question asking the imperfect world, what would be the the ideal recycling or the technology or something, no? Well, for that, probably that somebody in a perfect world thinking about how that also connecting that the situation in the waste management situation in the developing countries to do the product design, so, you know, like thinking about the global supply chains, and then also how it's ended up in that what, you know, like a totally different waste management system. But still could be a sustainable. So you know, so that's, I think, definitely that the responsibility of the producers. So you know, thinking about a bit more stretching out to the end of the life, that would be a great. Thank you.
Thank you. This has been fantastic. I've learned so much today, and I hope that all the attendees have learned a bunch, and that our panelists have as well. I want to thank everybody for joining, both as an attendee and especially the panelists. And I want to remind everybody that this is part of an ongoing webinar series that we're having with DC-MUSE. We have your contact information from the registration, and we will send you the when the next webinar is being held. And that check out our website, join us on LinkedIn, and hopefully this spurs conversation amongst your colleagues and at home, because this is a big problem that's not just technical. It requires policy, it requires consumer adoption, it requires the drive of what do we want to see as inhabitants of this world. And so I want to thank everybody again, and I wish everybody a good rest of their day.
Thank you.
Thanks.
Yep. Thanks, everyone.
Thank you.